All right. Seems like everyone is here. All right. So, welcome everyone to the Stateless Implementers call. Let me just find the agenda quickly so I can share it in the chat. This is call number 48. And there you go. The GitHub issue is in the chat. So let's get started with the agenda. We're going to start with team updates. So whoever wants to go first, go for it.
I guess I'll go. I was working on merging the transition code in Geth. Found a problem, or not a problem, but found a potential tweak to the spec that I want to discuss. Otherwise, we have been interacting with Karim, trying to get the testnet started. But before that, we just want to make sure we agree on the details. So I produced some blocks, and yeah, we agreed that this was not the right way to do this. So in fact, we will need to talk about it a bit later. How do we think? Yeah, that's pretty much it for the binary tree itself.
Yeah, no, on business side, so I know that Thomas is working on transition, but I don't have a lot of news on this part. But on binary tree, so as Guillaume said, we had some discussion. So I have a branch with binary tree in Bezu. I have to update it because the last time I updated this branch, I think it was some months ago. So if we want to run a testnet, I would prefer to run it with something that is up to date. So it's what I will do this week or next week. We'll see, but I think this week. And after, yes, to see with Guillaume how we can have this testnet running with Bezu and Get and maybe other clients. Mainly that on my side.
So from my side, I've been mostly working on two things. The first one is to add support for binary tree bloating in the state actor library from Tony, so that we can actually start addressing, and understanding specifically the performance that binary trees bring with worst cases and what are the gas limits that we should expect to be able to handle and otherwise improve the implementations. And from the other side, I've implemented the first version of the partial stateful nodes, which is being able to sync as of now. So I basically snapped sync the account tree plus DAI and USDC. And that took around 50 something gigabytes of database in like 30 minutes. So now that it's confirmed that we can actually snap sync only what we want from the state, I'm starting to rebase. Well, I actually rebased. I finished some minutes ago. I rebased on top of Val DevNet 2. And the idea is to now not only make sure that the snap sync works within a Val-enabled testnet, but also start testing all of the block processing for the Val and computation of the state root, check that we can actually provide or serve it get proof for the contracts that we're storing and all of this kind of stuff. So that's mostly it from my side.
Good. Anyone else before we jump to the next point? Good. Well, point number 2 is a point from Guillaume. So we're going to start with that. It's about, well, something you just mentioned in this update, but specification tweaks regarding transition using a system contract for storing pointers. So Guillaume, the mic is yours.
Thank you. Yeah, so I would like to talk about a tweak to the like last time I was talking about using an overlay, sorry, a system contract to track all the conversion pointers or the conversion state, if you want. Namely, what was the last account that was being converted, or what is the current account being converted? What is the next to be converted? And were like a couple more items, including whether the conversion has started, because the conversion starts after a week, right? We need to distribute the pre-image file. And whether the conversion has ended, because if the conversion has ended, we just go with a binary tree. We don't go with this middle facade pattern that does the writes into the overlay tree, but does the reads first in the overlay tree and in the transition tree if it can be found in the overlay tree. So I tried to implement that in Geth, and I found a bit of an issue, or at least it's very difficult to implement. And so I wanted to talk about the possibility of delaying the conversion by one extra block. So I'm going to explain what's going on. Okay, page not changing. Okay, yeah. So at the core, it's basically it's a bootstrap problem, right? The conversion status, if it's in a system contract, in the storage of a system contract, that means it's in the state. The state itself, as you all know, is represented by a tree. And because of that, it means that to read the tree, we need to know what kind of state that is, what kind of tree that is, sorry. So that means that, yeah, it's biting its tail. You need to know what state you're reading, what type of tree you're reading, to know what type of tree you need to read the tree so that you know what type of tree you open. So yeah, that's the problem. There's not many elegant ways to do it. So the naive approach, which is probably going to be the final one, but I want to suggest another approach before. You try to open both trees. So you first try to open the binary tree, and if that fails, well, the tree you have is an NPT. Of course, we're not going to do this all the times, or at least it's left to the client to decide if that's what they want to do. Maybe on the testnet or any testnet, any shadow fork, we don't really have to care too much about this kind of performance, but it's pretty bad to try to open a tree, and if it fails, you try another one, because there could be a genuine error in your database, and then yes, you just start from a fresh tree. So it's not a fresh overlay tree, so it's not very well. Okay, let's say there are errors that would not be caught, and that's not ideal. So yeah, the idea is that you try to open both, and the first one that works is the correct one. But that means that for us, we wouldn't want to do this all the time, so we would have to signal that the opening only happens after the attempt at opening the binary tree only happens after the fork. And if that is the case, then you need to pass a flag in the tree management layer. Something I focus in this slide, but is also very important, is that if the start of the transition is not already stored in the contract, which is what you do when you bootstrap, you have an issue, because you will not you will fail to create the binary tree. So you still have an issue with the bootstrapping problem. So that's a bit of a solution. That's a sketchy solution that probably is going to end up being the correct one, but it's very, very yeah. There's a lot of devil in the details, Yeah, I haven't managed to get it to work for Geth yet. The other approach is to use the one block delay. So once again, sorry for my poor penmanship, but this is supposed to represent, this is the fork block, so this is the fork slot, and this is the slot just before the fork. And what we do is we start with the MPT that we write to, and then at the fork block, we keep the MPT. So we don't bootstrap the vertical tree, or sorry, I say vertical, but binary tree or whatever, at all. But what we do at the end of the block is that we write a 1 into the started, like the leaf of the contract, the slot of the storage slot of the contract that corresponds to whether the transition has started or not. And so we write a 1, and that's all that happens for this block. So there's a delay because the first block after the fork is still 100% MPT. And then the block after, you see that when you read the MPT, so you open the MPT, and then you see that it's been set to 1. So you also bootstrap the binary tree. And then all the writes, because it's been created, you start from a fresh tree, but all the writes go in there. And as a result, for subsequent blocks, the MPT is always frozen. I mean, it was already frozen here. And all the updates go into the binary tree, and that means all the other conversion pointers end up in the binary tree. So the idea is that we're starting 1 block later than we used to in that model. I just also realized doing this presentation that this is more or less the case already, because we don't start the conversion right away. We wait for a week, so it's actually more than 1 block delay. What I'm saying is we could extend this period by 1 more block, and then at least it's a solution to this problem that I have. To be clear, this is totally connected to an issue in Geth, or at least the way Geth is written. It simplifies the code a lot. I'm submitting the idea to see if Besu, I guess, because no one from the other mind is here, would be amenable to that solution if they think it's too complicated, etc., etc.
So I think I had the same issue when I was working on the transition. So I found a way to manage that, but I think I will prefer your solution because it will also simplify my code. So I had to use some workaround method to fix this issue. So if we have something cleaner like that, I think I will prefer.
Okay, so that's
because on my side I had to to look at the timestamp when we are importing the block. I think I had the similar issue also on my side. So so delaying it's better. Yeah.
And to be fair, that method also requires looking at timestamps, or at least the block timestamp, at least.
Yeah, but I think it's the previous timestamp. It's not the timestamp of the block we are running. I think. Yeah, it's more matching the logic we have already in Besu, looking at the timestamp before, and for the transition I had to look at the current timestamp, so it was I had to add some different code just for that. So
yeah, okay, so that seems to align with our own problems. But then what do you think of this method where you just try to open both, right?
Honestly,
yeah.
Regarding that, I'm not sure to understand.
Well, once again, it's something I haven't managed to to make work, right? So it's probably not even a starter. But yeah, the idea is that when you detect the fork, like when the fork starts, you start reading two trees. Like you say, oh, okay, the fork has started, so I'm going to assume that I'm gonna read the binary tree, and if that fails, that means I'm at the first block, and therefore I need to bootstrap. So I need to go and read the route I'm passed as a MPT, but an MPT is not like the only thing. It's actually an MPT that is the base tree, and the binary tree is empty. So this is like something that's going to work for the first block, really.
So I think it's more related to get implementation. In Bezo, I was just looking at the timestamp, and depending on the timestamp, I was starting MPT or binary tree or transition tree, because I had this kind of transition world state where we have binary tree inside and MPT inside. But I was just using timestamp on my side. It was working correctly. So I think it's more related to your implementation, maybe, but.
But that means like this would not be of interest to you.
No, I don't think. Yeah. With timestamp, I think we can do it.
Okay, well, if you can do anything with timestamps, then good for you.
But we can maybe discuss about that maybe later, I think, because
Sure,
I'm not sure to see how. I don't know the get implementation, but it seems strong that we cannot use timestamp also in get. But
well, that's the thing. We should be able to, but yeah, it's a very intertwined piece of code. So once again, this is a 100% guess problem, at least 100% guess problem. Maybe it's also a problem for other people. Hence my presenting this. But yeah, if the second solution works for you, then maybe we can yeah, we can keep discussing, and if it turns out that's really the problem, then we change the spec.
I think I can try to implement the second solution and see if it's working correctly. I think it should work correctly with Bezo, but I can try to look at the second fix and see. Yeah.
Okay, perfect. Yeah, we can do that. Unless there's more questions, I know you wrote something. Okay, yeah, you are talking about timestamp. Okay, so unless there are more questions, this is all for me.
Thank you, Guillaume, for presenting this. So, since there doesn't seem to be more questions, we'll move on to the next item on the agenda. This is a presentation of ERC 8147, locality preserving storage layout for binary tree. This is by Han. So, yeah, the mic is yours.
Yeah. Just share screen. Okay. So I think it's going to be a short one because the idea is actually very, very simple. So the previous 6 calls, I think I mentioned about like doing something with locality as well. But that one is a similar idea where we want to optimize the locality as much as possible. But the previous one is an EIP where we are adding new opcodes, but I actually realized that that's no longer needed because we could just have to change. We just have to update the compilers to update the key derivation method once we migrate to binary tree. So a straightforward way to explain it. So let's say we have these 3 mappings in a contract. So the current MPT, what we will do is that we will hash it, and then those keys will be randomly distributed in the trie. So locality is bad, but we will have the same problem as well in binary tree, where even though we have the 256 values, but they are stored individually. So what we need to do actually is to basically update the key derivation method, the middle part here, for now it's something like this, where we are hashing the address, then we remove the last byte, and then you do an OR operation, basically replacing with the base slot index. So this will be done by the compilers. Yeah. So to do that, basically when we are generating the try key, so you can notice that it's sequential for this for the same address mapping. It doesn't have to be address. It can be and something else as well. I mean, depending on how the contract is written. But address is the most straightforward one. So if we do that, that means that we are these three mappings for a particular address, they will share the same leaf, basically the same page. So yeah, so that's basically the thing that we have to do. So yeah, that's it actually. So, any questions? Yeah.
So this is intended mostly to be used by for storage or for code, or what's the main...
storage. Yeah, I don't think like contract developers have to care. I mean, okay, they'll definitely have to be aware of this new optimization because the gas cost will change. But I would say the most of the work is done by the compiler side. Yeah.
Yeah, and what happens if we go beyond 256 chunks of storage?
For now, I don't think we have. I mean, I don't think we have 256 mappings at least. But if let's say we do, then I think it will be the compiler's job to actually detect that and then to adjust the keys correctly. I mean, we can fall back to the previous one, or maybe we can. I'm not sure if we can actually exceed it. Yeah. But yeah. That's a good question that we should check out. But I wouldn't say it's a big problem based on our current patterns on contract codes right now. Yeah.
Yeah, the reason why I ask is a lot of storage like proxy patterns are going to specify an explicit like storage location, which likely wouldn't map to the first like whatever number of storage slots indexes there are, and it would fall like somewhere probably beyond that because it's effectively just a random number in the storage tree. And a lot of modern proxy patterns use that. I'd have to look it up, but I know I've seen it used quite a bit. So yeah, I don't know.
Okay. Yeah, I think that's a good point. Yeah. All right.
Yeah, I like the idea. It's really simple. So I like the design.
Nice. Okay. Stop sharing. Yeah.
Sorry, just a question. So the structure you would be targeting are mappings, right? Not because like in the case of an array.
Yes.
You would have, I guess you could use this for an array as well, but so that means, I guess it doesn't matter because
It still be the same.
31 bytes of security.
Yeah.
Okay. Yeah. No question. That makes sense.
Yeah. Okay. Cool. I'll pass it back to you, Gabriel.
Nice. Thanks. Cool. So that brings us to the last point of our agenda, number 4. It's by Carlos. So it's binary trees, redesigns, and performance considerations from themes.
Yeah, hello. I don't have a visual presentation, and I mostly wanted to introduce the topic and see what other people think. So lately, I've been working on several stuff. One of them was this partial statefulness idea, for which I'm working on in Geth, and the realization I had is, I mean, it's fairly obvious, of course, but is that the current MPT design basically embeds within the topology some dependencies, but also some advantages. So, for instance, for partial statefulness, one of the main things that we take profit from is that we can discern between the account tree and the storage tries of every single contract. And that is really useful because that allows me to actually snap sync only the accounts and only the contract storage that I want to have. So when going to a binary tree, if we go unified, basically, that means we lose everything here. Like there's no way anymore to know what is an account and what's not. And I was basically trying to seek some feedback from people on whether we actually value more having the tree to give us meaning for what we are looking at in the storage, or we actually value more the fact that we have fully unified tree. Does anyone have any takes on that?
Oh, I think we can still have the like topology in a unified tree, right? But maybe we have to sacrifice a bit on not sure about security side. I think it's the same idea as what you mentioned in our internal meeting last time, where the left portion of the tree is for accounts and some portion is for storage. So the partitioning is very clear. But I'm not sure if doing that in a unified tree will still be suffice for partial statefulness.
Yeah, so there are several things here. One is we could just have two trees, because one of the main benefits or why we want to go towards a binary tree is, first of all, smaller proofs, but no one is really using proofs anyways, besides SnapSync. So, I mean, I would love for this to actually matter, but so far it doesn't look like it. But the second one is that the state root computation actually becomes, let's say, as optimal as possible, in the sense that if we have a unified tree, the probability of the storage slots that we are touching to recompute the state is that basically they are distributed across all of the possible subtrees, and therefore we should not have any hot paths, whereas this is, of course, not the case in the MPT. But if we could actually get something that also tries to avoid these issues in the state root recomputation, like having two roots or distributing the keys by prefix. So basically accounts go to all of the 0, 1 prefix, and storage goes to the 1, 0 and 1, 1, or I don't know, something like that. Would this actually make any sense? Like, is there anyone that has actually thought about that? We just consider going to binary uniformly and no one really cares. Like, I mainly wanted to get ideas and feedback from people as we are working on trying to see if it makes sense to redesign a bit the binary tree, since we are on time. And yeah, and basically I wanted to hear thoughts, if there are any.
So when you say redesign the binary tree, you're mostly wondering about, so you mentioned now like distributing uniformly like the accounts. Are there other, like there's also, I think it would be helpful to break it down into different architectural sections. So there's a leaf design, there's the way that the account keys are computed, there's the fact that it's actually binary, like two always two. What facet of those would you like to get in most input on?
What I want to get input on is basically whether we value more the fact that the tree is unified, so we have just one tree, or we value more that the tree has topology within it, like the MPT, so we know when we are iterating over accounts and when we are iterating over storage. And basically we have this domain separation, which comes in handy for several stuff, like the archival state expiry that Guillaume is working on, like the partial statefulness that I'm working on. All of these solutions exploit that when we look at the database, we know if we are looking at accounts or looking at contract storage, and what type of contract storage are we looking. And so there seems to be this trade-off between whether we have one thing or we have the other, or we have a really weird thing in the middle. And I was basically asking whether anyone has hot opinions or yeah, I don't know how to say it, like strong opinions, sorry, on any of both paths.
Cool. Yeah, thanks for clarifying. Karen seems like he has something to share. Yeah, go for it, Gottfried.
I mean, Karen can also go before.
No, go ahead. Go ahead.
I mean, maybe it's just an opinion. I mean, since you asked for it. I mean, first of all, I mean, whether you have basically, if you sort of do this kind of domain separation, then internally, of course, this amounts essentially to just having separate trees. I mean, if you just look at everything from below the, I don't know, 2 layers below, and you just look at the root, the intermediate roots in a big unified tree, then these are basically separate state trees for just a portion of the state that corresponds to account, storage, code, whatever. So in a sense, it's actually nice that you can view it in both ways. From a security point of view, I mean, the fact that it's no longer completely evenly distributed, but rather, I mean, inside some subtree of maybe a bit of a smaller size, I think it does not make that much of a difference, at least if you're looking at worst cases, because if somebody wants to sort of craft some block where a lot of accesses happen on the same hot path, they can just do this, and whether you have whether you have it spread out or not does not really affect this, at least not for adversarially created blocks. And the third reason is maybe the more interesting one, is that I think that in the future we might need to sort of have different tiers of state, like, I don't know, a state that is only temporary, or that automatically expires, or that is sort of accessed differently in a parallel fashion, or whatever. And sort of making these kind of things with a prefix thing basically opens up at least future updates that make much more strong distinctions between different tiers of state. So just from a point of view for future safeties or upgrade safety, it's probably better to use a design where you have a bit more structure in the tree. But that's just my opinion.
So that, I mean, all good points. One of the things that I was basically thinking, which is kind of in line to what you said, is if we go with the prefix idea and we have, let's say, 2 trees, they are uniformly distributed inside, but of course the fact that accounts or EOAs are in one place and contract storage is in the other definitely creates an unbalance there, right? So what I was mostly kind of trying to understand is, if we do this like key distribution and we have only 1 tree, but we distribute with key prefixes, so basically everything that has 00 is an account, EOA, and then whatever has 10 or 11 is contract storage. The problem that we have with this is that we never actually know if the ratio that we're picking is good enough. Basically, now the ratio is accounts occupy 14 gigs, more or less, and contract storage actually takes the rest, basically, minus, of course, intermediate nodes. And so maybe this ratio changes in the future, and therefore the imbalance is even greater. Besides that, and from a security perspective, I'm not really sure how is it worse than the MPT, meaning it is actually not, worse, but maybe I'm missing something. So can you actually elaborate a bit more?
I mean, on the security point of view, I mean, okay, let's assume it is imbalanced. Why is that even a problem? Because, I mean, the question is, of course, on the database layout internally. I mean, nothing stops you from basically internally having 2 different databases, right? I mean, you would have, even though sort of the tree is sort of the same, sort of from a database structure. I mean, you could basically store everything that sort of starts with 1 in a different path access database that is maybe smaller, and the other one, the keys that start with, I don't know, 00 in another database. And I mean, the only thing where they basically interact is in the final step of the safe root computation, where you basically hash the root of the one and the root of the other.
O sigui, necesitas algo de mí urgent ara?
Sorry, Carlos?
I think he's unmuted.
Okay.
No tinc cap gotera jo fins on...
Carlos, you're unmuted.
Yeah, I muted him.
Okay, yeah. I mean, and also, I mean, okay. So what happens if one state, if one of these things is sort of smaller, that does not really pose a problem, because essentially the cost you have per access basically depends on the depth of the whole thing, of the tree that you get. And just because one of the trees is smaller, I mean, if sort of you have a lot of accesses into the small part, I mean, most is off by almost a factor 2. If you have a lot of accesses into the small part, then these accesses actually become cheaper. So it would only be a problem if most of the accesses are in the big part, but there you only lose one layer at most. So, because even if you add sort of the small layer to the top layer, to the small part to the big part, the only difference is basically one layer. So it's basically a +1 difference as far as tree depth is concerned. So it's not a big deal. In fact, it might be it's potentially even an improvement.
Sorry, I got the seat. I in line with that. One thing that I'm not sure if the guys from MegaETH or who it was, but if we keep this separation, one of the good parts is also that we can keep the account tree still separated, and we could potentially put it into RAM if RAM happens to become much bigger and much cheaper in the future. So even we could still recompute state root faster, at least in one side, and we can cache also in RAM the first levels of the storage tree, if that helps on something.
Yeah. I just think that sort of this distribution thing is just not really an issue.
Oh, okay, I see. Okay, that's nice. That's good news. Why is not?
I just said before, but you were a bit offline. The reason is basically, I mean, if you basically just separate it into two parts, I mean, if you have a lot of accesses, either it's, so you say you have a very imbalancing, you have a small part and a big part. If most of the accesses are into the small part, that's actually better than if they're in the big part, because the cost, the thing that we depend on is actually not that they are spread out. The spreading out is not an end goal in itself. It's only the spreading out is just there in order to make sure that the depth of our tree, binary now, does not grow too large. But if a lot of accesses are into the small part, this will have just a lower depth. So you have a lot of accesses with lower depth, which is good. And if you have a lot of accesses into the bigger part, then you're basically paying some extra in some sense, but the amount of extra you pay is at most of one layer. So it's just a +1 in terms of depth on a binary tree. That is basically the worst thing that can happen with this thing, which basically accounts for this extra prefix.
Yeah, I think for performance reason, I think the way I see it, doing the domain separation, separation is going to be much easier to, for example, like there's one domain, there's one region that you can cache for sure. But if you are going with the current unified tree, I don't think, I mean, it's still possible, but it's not that straightforward from what I can tell. So I think also on the performance optimization side, I think doing the separation would be better.
Yeah, from my side, only I wanted to add one thing to this, which is one of the things I want to start benchmarking as soon as possible, as soon as I can get the dB of Geth in binary tree mode bloated, is in the MPT. I've recently discovered on the stateful benchmarks that what actually affects the performance on stateful recomputation isn't only the depth, but also the size of the contract that you are basically fetching nodes from. So I want to basically run some analysis and see what affects more in that, because what could very well happen is that depth is what leads the cost. And so in binary trees, we usually have the worst depth always, which is the average case. So yeah, I'm sure if anyone is interested on these numbers, but I can forward them as soon as I get them.
I mean, just one thing to sort of add here. I mean, you have to be a bit careful about sort of the worst case for sort of maliciously crafted state parts, because an adversary sort of could basically create state that is unusually deep.
Sorry, can you elaborate a bit?
I mean, just be aware. I mean, if you're sort of looking at average, if you're looking at average case performance, because I mean, it's actually not terribly difficult to create a lot of state that sort of collides in the first bits. So you have sort of a part of the state that is actually much deeper than much higher depth than sort of what the average case would sort of suggest by something like 10 or.
I see. So you mean we are safer, if I understand correctly, as it should be harder to craft those nodes, or you mean the opposite?
Harder compared to what? In what case? Binary versus MPT case?
Yeah, exactly.
Slightly, but it does not make much of a difference. I mean, the depth is just generally bigger because it's a binary tree, right? And it does actually get a bit harder to make something with higher depth. I actually computed this once. I would have to look at. Maybe I can get back to you by Telegram or something. It gets a bit harder, but not by much.
Okay, I see. Because I have in the execution specs, I uploaded some worst case benchmarks for depth, and I mined. Combine the account tree and the storage tree of the contract. It was, I think, like depth 20 something overall. And then what I did is, since the slot index is the same in all contracts, I could basically just copy paste this huge branch to a lot of different contracts who all fell into an account that was also really deep into the account tree in the MPT. And that created a really bad case for the entire MPT when recomputing the state root, because you are in the deepest part of the tree for all the contracts which you have deployed. But I'm not sure that I can do this in the binary tree as easily because the depth is much higher. So I will probably run out of compute, but maybe I'm missing something. But yeah, I also am not sure that I can find these things as easily. So maybe if you can give me some of your, I don't know, you've thought about this and maybe you wrote some code or whatever. So if you can give me any resources, that would be useful.
Yeah, I mean, I wrote down something on this. I don't know, something like 1.5 years ago. It was probably not up to date, but I can give you a link.
Thank you very much.
Yeah, so one extra comment, since you were asking for comments, is that I'm not sure. I mean, okay, I get an idea why, but we already mentioned similar ideas, not exactly the same idea, but we did mention to Vitalik the idea of taking the code out of the account header. And the problem with this is that, okay, that's not what the problem is, but Vitalik was not super happy with this idea, simply because I think he likes the fact that when you open an account, you get all the data in one that you need, okay, that small contracts need in one swoop, because you get the account descriptor, you get the first few slots, which is what smaller contracts need, and because variables tend to be stored at the beginning of the storage space, and then if you have a hash map or actually just a hash map, yes, it can jump all over the place, but typically the compiler will store everything at the beginning of the state. And if you don't have much code, then everything will be accessible in just one dB read. So that's the first aspect of it. And the second aspect of it is that if we separate the code from the code, of course, but the storage from the account, is that you will need to prove more leaves per access, per account access, or at least contract access, and this might make the witness bigger. Now, these are not my opinions. It's just me channeling somebody else's opinion after a conversation from like a few months back. But I think that in order to decide on a model like this, we need to prove that we need to have numbers on what the average witness size would be, which in the case of a binary tree is a bit annoying because it's going to be bad compared to BALs, and it's going to be bad compared to ZKVMs. So maybe with ZKVMs, it doesn't matter as much anymore. But actually, yes, it does, because you will still need it for syncing. You will still need it for things for RPCs and things like that. But yeah, like just we need to measure the I would say the performance. If it turns out that reading in one location of the tree and then another location of the tree is not as bad, then it doesn't make any difference, and we might as well do the more rational thing, especially if the average performance is much better, like what Goti was saying. And then also look at the witness size. Yeah, these recommendations.
All right. Well, thanks again for the engaged discussion, everyone. I think that settles that part of the discussion, right, Carlos? Was there anything you'd like to add, or closing remark, or
No, that's good enough. I'll maybe write about this and publish on his research or something, and try to gather more feedback. And I will also get all of the performance numbers so that we can come and discuss again, but with data. Thank you.
Amazing. Yeah, thank you. Cool. So unless someone wants to take those last 10 minutes for something relevant, we're going to close this call a little bit early because we've just run through our today's agenda. So yeah, I'll leave like a 10-second opportunity for someone to chime in, but otherwise we'll close this now.
I guess most people are gone, so it doesn't really matter. But I wanted to say we're trying to organize a Stateless Summit in HCC next March. Actually, it's going to be April 1st, so next April. Yeah, so if anybody hasn't signed up yet for that, please sign up. We're going to have some conversations. We're going to have some presentations. And I'll keep shilling it over the next month. But yeah, I wanted to share that info.
Great. Yeah, thanks for sharing, Guillaume. All right, thanks everyone. That closes this call. I'll be sharing this summary shortly, and we'll be tweeting about this this week. Thanks.
Bye.
Bye-bye.
Thank you. Bye.
Bye.
Bye.